Good evening, participants. We welcome you for this one more session on our Aero India webinar 2019. We have a distinguished panelist today who has been very kind to take a session on Aero India's 2019 webinar. Shri A.S. Kiran Kumar, former Secretary, Department of Space and Chairman of ISRO is here. He's going to take a wonderful session, and I hope the participants will enrich with the knowledge sharing session from the distinguished scientists and panelists. We thank you participants for taking your valuable time and for taking part in our webinar series. And this webinar has been moderated by my colleague, Ms. Bhumika. She will help us and guide us and also help the participants and panelists throughout this webinar. Thank you very much one more time. I request Bhumika to take over from here. Thank you.
Thank you, sir. A very warm welcome. Good afternoon. Namaste to all our participants. My name is Bhumika Suri. I'm from the National E-Governance Division, Digital India, and I'm your moderator for today. Today is the 8th webinar of the pre-event series of the webinars being conducted by the Aero India 2019. This is a collaborative effort of the NEVD, Digital India, and Ministry of Defense, Department of Defense Production. This is the first time such webinars are being conducted, so I hope you take advantage of the knowledge which is being shared with you by our eminent speakers. Before we begin, I will take you through certain housekeeping rules. So as you see on your screen, this webinar for today would last for around 1 hour and it will finish at around 4 p.m. Indian Standard Time. I would request all the others to please keep their microphones and cameras switched off when they're not speaking. There is a chat option available for the participants. If they want to give some feedback on the audio-visual quality or any other settings issue, they can please let us know through the chat option. There is a Q&A section also available on your screen. So if you have any questions related to the technical content of the webinar today, please put those questions in the Q&A section. We will be happy to take these questions. If the time permits, at the end of the session, of the Q&A session, we would take some questions live. So we would request that time to please raise your hands. The people who raise their hands, please make sure that you have your audio settings in place. You have a mic and a microphone and audio settings so that you can take the question live. We also have a poll at the end. So please rate the quality of the webinar at the end of this session. There is also YouTube live streaming going on the Digital India Learning channel. So we will share the link shortly with you. We hope you subscribe to this channel so that you can have benefit of the other webinars as well. Now I hand over to Mr. Sunil Kumar, who is Director Operations HAL in Bangalore. He's joining us from the HAL Bangalore. And he will give us an overview of today's topic and give a detailed introduction to our speaker today, Mr. A.S. Kiran Rao, former Secretary, Department of Space and Chairman, Indian Space Research Organization. Also joining us from HAL Bangalore. Over to you, sir.
Hello and good afternoon, ladies and gentlemen. I am Sunil Kumar, Director Operations, Hindustan Aeronautics Limited. I welcome you all for the 8th webinar in the series of webinars being conducted in the run-up to Aero India 2019. Aero India 2019, the premier aerospace event, is the largest aero show in Asia, organized in the beautiful city of Bangalore from 20th to 24th February 2019. Coming to today's webinar, the topic is Indian Space Program and Future Technologies Needed for Ground Aerospace Activities. The talk is being delivered by Shri Kiran Kumar, former Secretary, Department of Space and Chairman, ISRO, and is presented under the aegis of Aeronautical Society of India. He will give us an insight on Indian space programs and future technologies needed for ground aerospace activities. I take the honor of introducing Padma Shri A.S. Kiran Kumar, a renowned personality in the field of aerospace. Sir is Vikram Sarabhai Professor, ISRO. He has held various eminent positions and has served as Secretary, Department of Space, Chairman, Space Commission, and Chairman, Indian Space Research Organization. Also, he has been the chair of the Committee on Earth Observation Satellites in 2012. Having obtained his physics honors degree from National College, Bangalore, and MSc Electronics from Bangalore University, completed MTech in Physical Engineering from Indian Institute of Science, Bangalore. Mr. Kiran Kumar has steered the implementation of applications-oriented Indian space program, which has facilitated rapid development of the country in many important spheres of Earth observation, communication, navigation, meteorology, and space science, as well as the development of indigenous launch vehicles and related technologies for providing assured access to space. He has contributed to the design and development of more than 50 electro-optical imaging sensors flown on spaceborne platforms, starting from Bhaskara TV payload in 1979 to the payloads on board the Mars orbiter mission in 2013. Has played a crucial role in Chandrayaan-1 mission right from the conceptualization stage and made exemplary contributions to the success of Mars orbiter mission and reusable launch vehicles technology demonstrator, which made the entire nation proud. He has made valuable contributions to coordination group of meteorological satellites, expert team on satellite system, World Meteorological Organization, and Indo-US Joint Working Group on Civil Space Cooperation. Indeed, his contribution to the world of Indian space program is a valuable gift to the nation and an important contributor to fulfilling its aspirations of being a leader in the world space program. Sir Kiran Kumar is President-elect Aeronautical Society of India and Fellow of Indian National Academy of Engineering, National Academy of Sciences, India, and various other eminent institutions. He has been conferred with honoris causa and DSc by 16 Indian academic institutions. He has co-authored 85 publications. In recognition of his contributions, he was conferred Padma Shri Award by the President of India in 2014. Various state governments have also honored Sir in recognition of his valuable contributions in the field of science, space, and innovation. Shri Kiran Kumar has been conferred with the prestigious 2018 International von Karman Wings Award instituted by the Aerospace Historical Society in collaboration with the Graduate Aerospace Laboratories at the California Institute of Technology on November 8, 2018. Today's talk will cover the current Indian capabilities in the areas of Earth observation, space-based communication and navigation, and the synergy of applications and users community. The ongoing efforts towards establishing space infrastructure, space transportation system needed for the meeting the future program with the participation of Indian industry, enabling them to play greater roles in the vital area. I invite Shri Kiran Kumar sir to kindly present the webinar.
Thank you, Sunil, for the generous introduction. And it is indeed a great privilege and honor to be presenting about the Indian space program as part of the Aero India 2019 webinar. And welcome all the participants for this program. Okay, so what I intend to do is take you through the development that has happened in the Indian space program. And if you look at the Indian space program itself, it has established a technological capability, building satellites for communication, Earth observation and navigation, an indigenous launch capability, devising applications for socio-economic development using space technology. It has been a very cost-effective space program. We have had lunar and Mars mission and careful planning and execution, then systematic policy for indigenization and industrialization contributing to national economic development. In this process, handholding and technology transfer and spin-offs have all been the activities that we are doing. And today we have in the space program 4 major elements: space transportation, that is to take the object from ground to space, various launch vehicles required for that; space infrastructure, which is a set of spacecrafts or satellites in operation in space, and using them, generating applications. And beyond this, we also have a capacity building, which is capacity building not only within the organization for enabling space technology, but also capacity building in the country, both in terms of the industry and academic institutions. And in terms of, if you look at accomplishments, we have done more than 70 launches so far and about 100 satellite missions and some 8 technology demonstrator missions and a large number of applications encompassing communication, Earth observation, navigation, and space science. And today we have, if starting from the early 1980s, where based on a series of experiments conducted in the country to demonstrate that the space technology is the route to take for developing our communication capabilities, starting in the 80s with an Ariane passenger payload experiment and the INSAT series. Today we have a host of almost about 19 communication satellites providing us ability to do in various frequencies, C, S, Ku, Ka, and also high throughput capability. And it caters to various application areas, whether it is contribution to domestic broadcasting services or VSAT connectivity for ATMs or various transactions, stock exchanges and other transactions, or direct to home television sets. And for this, we are adding in the very recent days the capabilities like GSAT-11, which is a very high throughput satellite, which covers India in about 16 beams, encompassing all parts of the country and capable of providing higher bandwidth, almost up to about 14 gigabits is going to provide. And these features are now becoming operational. And another important area where we have made progress is in satellite navigation, where Gagan, along with the aeronautical societies and also the Director General of Civil Space Aviation Sector, Jeep Gagan, which is a GPS-aided geo-augmented navigation system, where the government has already made it mandatory for all aircrafts registered in the country to carry this satellite-enabled receiving system, where safety of life and integrity of service is guaranteed. And this has become operational, and all aircrafts registered in the country beyond January of this year have to necessarily carry this satellite-enabled receiver, which helps both en route planning as well as for landing activities, a significant improvement. And Navit is another system where we are making use of a constellation of only 7 satellites. And unlike what the Americans, Russians, the Europeans and the Chinese have done, we have gone in for only a 7 satellite constellation operating from geostationary platforms. And this, along with a number of ground segment receive stations for evaluating the quality of the signal and also providing inputs to the satellite system. Today, this has become operational, and already one of the mobiles carry NAVIC-enabled signals. And this is a service which is again a very innovative way of providing cost-effective solutions from space program for the problems we face. And you will see in a subsequent slide how this NAVIC system is enabling actually the fishermen and other community to make use of the space technology. And in terms of Earth observation satellite systems, if you look at starting from Bhaskara satellite way back in 1979, where we made use of the Indo-USSR friendship of them providing an opportunity to launch 2 satellites. We built Bhaskara series of satellites, and then gradually over a period of time increased our ability to provide higher resolution imaging system. Today we have, you can say, from 1 kilometer to almost 60-meter resolution from a geostationary platform. That means practically every second we can see an area of 100 kilometers by 100 kilometers at 60-meter resolution in 6 spectral bands. But apart from that, we have designed and devised systems which are exclusive for Indian usage. As you are aware, we have a very small land holding, and to enable agricultural production estimations, we have what is called a 3-tier imaging system. And you not only having visible and infrared, but we also have imaging instruments which can operate in microwave domains. And meteorological satellites is another very important area where both from geostationary platforms and low Earth orbiting platforms, both microwave, optical and infrared imaging systems, which helps providing information, whether it's about the temperature and humidity profiles or about the wind vectors of the ocean. And this information is provided not only to the people within the country or the meteorological community within the country, but also to the weather modeling community across the globe. And within 180 minutes of acquiring this data, it is made available to them. And this is an important input to the meteorological activities of the globe. And today, we have an ability to look at from the geostationary platform at infrared and the sounding capability. Every 15 minutes, we can take observation of India and its surroundings. And for this, a number of different technology systems have been evolved, making use of what is called a push broom technology, one of the early adopters of new technology. Then 3-tier imaging system. It is this 3-tier imaging system which enabled India to actually capture the imaging market between 95 and 99, because in the civilian domain, we had the highest spatial resolution imaging at that point of time. And we also have a stereo imaging system, which is specifically designed for generating the digital elevation model, not only of our country, but also the various parts of the globe. And in terms of geostationary platform, we have 2 instruments, 3SAT 3D and 3DR. Together, they provide a huge amount of inputs for the weather community. And it is this set of data which helps us actually achieve both cyclone track prediction and also the landfall prediction very accurately. As you can easily visualize that during the months of June to September, India is covered with clouds. And if you are trying to observe from space the Earth, you will be encountering clouds. And to overcome the clouds, you can make use of microwave wavelengths, where in these microwave wavelengths, data appears transparent, like we can see through the glass in the visible wavelength. In the same way, we can make use of microwave signals for looking at Earth, and it is using these synthetic aperture radar and altimeters and also scatterometers that we are able to generate very important information that is required for various application activities. And recently, we have added to our capability a hyperspectral imaging system. Just in the November of last year, we have one of the few hyperspectral imaging instruments with the technology elements developed within the country. And this is a unique capability which helps in improving our knowledge about the crop pests, crop diseases, and also various other application activities. Today, based on a series of Earth observation satellites, then navigation satellites, and also the digital elevation model for the country, and a series of models and techniques, socioeconomic security, sustainable development, disaster risk reduction, and governance. In all these areas, we are able to provide solutions to the country. And in terms of these informations, if you look at one of the very key applications based on the space technology has been providing information to the fishermen. I would like to just narrate a small story here. When Dr. Vikram Sarabhai started the Indian space program, the first sounding rockets which were launched in Tumba Equatorial Rocket Launching Site, he had to make use of the friendship, he has to make use of the actually services of a priest of a church there to convince the fishermen that you should vacate this place for us to conduct the experiments. If you do that, one day in future, you will benefit from this technology. As though to demonstrate that from 1999 onwards, by looking at the color of the ocean and also the thermal fronts, we were able to provide to the fishermen the prospective fishing zone information, which tells them where to go for fishing. And to this, we have added recently through our NAVIC a capability, a very small gadget is fitted into the boat of the fisherman. And when he is in the ocean, through the NAVIC, a messaging capability, a handheld mobile in the hands of the fisherman gives him in the form of compass needle direction to the prospective fishing zone, and it also alerts him of any weather vagaries that could occur in the coming days, whether sea state roughness is going to increase or the wind is going to be very heavy, and then he had to return to safe zones. And also if he is coming anywhere close to international boundaries. So by this, a person who is not capable of reading or writing, he can get a compass needle based video indication to his job or his livelihood of catching fish, and also get all the information in his mother tongue using a mobile app. So a person who does not know reading or writing can take advantage of the space technology and do his livelihood. This is an excellent example of what space technology has done. Apart from this, today a host of applications for monitoring the various activities which the government does in terms of geospatial technologies has been done. And we have developed a number of portals like Bowen Portal, which houses the decades of information collected from space and which can be beneficial for various activities, and also weather information and a series of applications. And in addition to that, we have also developed a finite element analysis software for structure and thermal. And in terms of climate and environment monitoring, there is a web portal available at National Remote Sensing Center, which makes use of the data for terrestrial, ocean, atmosphere, cryosphere, and the likes. While we are doing all these space-based observations of Earth, we have also been doing space science experiment where the few of the activities which have caught the imagination is the Chandrayaan-1 mission and also the Mars mission, where before I go to Chandrayaan-1 mission today, we have been putting our satellites into different orbits, whether it is equatorial orbits or an inclined orbit or a geostationary orbit or even interplanetary orbits. And we have gone up to, you can say, a distance of 225 million kilometers from Earth, starting from between 500 to 1,000 kilometers to geostationary of 36,000 kilometers, then Moon at roughly 4 lakh kilometers, and Mars, which is around 225 million kilometers. So all these places we have been able to put our objects. And in terms of interplanetary or planetary missions, Chandrayaan-1, what it did is, while man had landed on the moon and a large number of probes had gone around the moon, this Chandrayaan-1 mission gets the credit for discovery of presence of water molecules on the moon and also the process of water molecule formation. That credit goes to Chandrayaan-1. And in the same way, the Mars mission actually has shown that we can do interplanetary missions at a much different time and cost scales. And this shows you some of the capabilities of this particular mission. And India happens to be in its maiden attempt, succeeded in putting a satellite into the Mars orbit. And today, after 4.5 years, and it is still performing well, while we had expected that it would last for only a 6 months mission. And for doing all this, we definitely need to build our own launch vehicles. So starting from sounding rockets, which was done in the 60s, we have been building continuously our capability of satellite launch vehicle, augmented satellite launch vehicle, PSLV and GSLV. And to this, we are constantly updating our skills and R&D efforts of improving using reusable launch vehicles and also building semi-cryo engines and also locksmith, liquid oxygen methane engines. And if you see the evolution of our polar satellite launch vehicle, starting from way back in '94, progressively we have been adding capabilities to this launch vehicle. Today, it is considered as one of the very reliable and credible launch vehicles. As a result of that, we have been able to put more than 270 customer satellites of 34 countries, and of which the one launch in 2017, which made history, was 104 satellites. When it was put in a single launch, the entire world turned around and looked at India. And one of the key things was the video which was released on that day, showcasing the release of every satellite, made in less than 12 hours more than 1.5 lakh downloads across 100 countries, showcasing the kind of interest that it had generated. And we also developed our own geostationary satellite launch vehicle, which help us put our communication satellites and other satellites into geostationary orbit. And in this, indigenous realization of cryogenic technology has been one of the hallmark. And today, we have more than 2 versions of this cryogenic engine, which is totally indigenously realized. And we have the second version, which is capable, what we call as GSEV Mark III, which is capable of putting up to 4 tons into geostationary transfer orbit. And continuous efforts to improve this is in progress. And as I said, while we are building these capabilities, world definitely is not stagnant or stationary. We need to continuously look at how we can reduce the cost of access to space by building new capabilities. And in this, one of the things we had done is a reusable launch vehicle technology demonstrator, where a winged body was brought up to a height of 100 kilometers and more than 6 Mach number. And on its descent, its complete control system was exercised, and we did a virtual landing on the water. And this demonstrated a huge technological design capability and many new observational capability required for handling such aerospace vehicle was demonstrated. And we also did what is called as a scramjet equivalent, where up to 19 seconds, hydrogen and oxygen, with the oxygen picked up from the atmosphere, was used and flame sustained. We are making progress in this, and in the coming days, you will have the next versions of the reusable launch vehicle and improved scramjet engine operating. While we build all this, we also have a 180 nanometer technology CMOS fab in operation in Chandigarh, wherein the processor chips required for our launch vehicles and some of the satellite payload instruments, processor chips, and also the imaging sensor, what we used both for the hyperspectral imager and also very high resolution imaging system, comes out from this fab. And this fab is the only 180 nanometer technology fab available in the country today. And then recently, as you may be aware, the government has also given the task of carrying humans into space and bringing them back safely before the 75th anniversary of our independence. And work has started in right earnest on this, and the huge amount of activity that is required for this. Some of the work that had been done earlier was crew module re-entry experiment, and also the spacecraft recovery experiment, where an object had been in orbit for 15 days and was brought back, bringing in the tiles, the heat-resistant tiles that were required. A large amount of technological developments that were needed have been done. And then the Gaganyaan program in the coming days and months and years is going to provide a huge opportunity, not only to the industry, but also to the academic institutions to work on a significant amount of areas where the R&D as well as developments will be needed. And Gaganyaan program is going to bring in a huge amount of impetus on science and technology in the country. And then if you look at in terms of aerodynamic journey of aerodynamics in ISRO, starting from sounding rockets and continuously making use of various software, some indigenously developed, and also computer systems, high-speed and high-performance computer systems, and establishing shock tunnels and hypersonic tunnels, and making use of a large number of software elements and simulation activities has been going on. And as we venture into our next generation designs, more and more of aerodynamic studies will be required. And this shows some of the examples of the kind of studies that have been done using the capabilities that were established, both in terms of the hypersonic shock tunnel and wind tunnels that are established in the country. And then this shows, for example, we also established a 450 teraflop computer system. Now we are augmenting it to something like 3 petaflop system. And then for doing all this, we need to also make sure that a large number of aerospace material requirements are there. These materials have to be developed, and whether it is a component performance or weight reduction or temperature stability or compatibility with the new demanding scenarios in space, all this requires a huge amount of technology elements and developments to ensure that we achieve success in the coming days. And for this, we also need to worry about not only the material design, their properties, ability to characterize them, manufacture them, and bring down the costs. And then materials for launch vehicles, if you look at, again, today we have probably the third largest or the second largest solid propulsion system, but then a huge amount of subsystems are being designed with indigenous material realization. This gives you an example. And this is a process which is going on continuously right from the 80s, where some of the materials which are not available to us by virtue of various restrictions have to be developed indigenously. And not only that, to ensure that you have self-reliance and not necessarily self-sufficiency, you need to make sure that you develop those components which could become bottlenecks in the coming days and years due to various geopolitical scenarios. So this shows you a large number of activities which are being done in the country, within the organization, and also with various institutions across the country. Industry participation has been one of the hallmarks, and as you can visualize, being a government institution, the manpower is always going to be an issue. And if you want to make significant impact and to meet the demands of the coming days, more and more industry participation and industry work is essential. And in this, we are making significant headway by bringing in industry partners to take up in the activities, including the consortium formation. Recently, including HAL, a set of industries have come together, and they are going to start making our PSLV stages to start with, and gradually the entire PSLV itself will be realized through the industry. And even today, we do almost 80% of our launch vehicle activity by making use of more than 300 industry partners in the country. And these activities are only going to increase because the government has already given approval for launch of almost 60 launch vehicles in the coming 4 to 5 years. And to this, the Human Space Program mission has been added. And this makes sure that the amount of work that is there is enormous, and it can happen only when you get into more and more advanced technology realization through industry and academia. And then use of new capabilities, whether it is additive manufacturing. We have already flown a number of components in our payload system, whether it is antennas or whether it is mirror fixation devices. But in the coming days, more and more additive technology is also going to be used. And for doing all this, a large number of facilities are required, and these have been established across the country within the organization. And I'll touch upon few of the elements which are going to be required for ground network and receiver development. NAVIC, as you can visualize, is going to be a sort of a game changer because it can provide various capabilities both for navigation of aircraft, helicopters, or even UAVs or drones. In all of this, the NAVIC-based receiver system can become the heart of the navigation capability. And today, we have a number of companies working on the receiver system development, and these receiver systems can be fitted into a large number of application activities. And we are also working on seeing how we can make in some front-end chipsets or even antennas designed for this. You will be happy to know that already one company has brought in a mobile chip, and a mobile has already come into the market, which is capable of receiving the NAVIC signals. And in the coming days, there will be more and more such things going to happen. And by making use of these kinds of small miniaturized electronic components, there's a huge opportunity for addressing the navigation requirements of the country in all kinds of vehicles, whether it is airborne or even on the terrestrial, including for the railways, etc. Now, we are also working on one of the things is, as you are aware, a large number of airports are going to come into the country. And if each of these airports have to have precision landing capability, pseudo-light systems will be necessary. And experiments are in progress for demonstrating the capability of such systems establishing near the airports. And in this is another area where there is a huge potential for making use of the navigation systems for both aerospace industry. And then we have a few of these spaceborne systems which have been brought into aircraft version. As you are aware, we have actually a Chandrayaan mission where L and S band synthetic aperture radar miniature version is being flown. And what we have done is we have made an aircraft version of this and flown on the aircraft. And then we have already demonstrated that this L and S band synthetic aperture radar can get into aircraft. And this example, what you are seeing, is a miniaturized X-band high-resolution system weighing less than 10 kilograms, which can be fitted to aircrafts or drones or heavy-lift drones or even unmanned aerial vehicles. And it can do a huge sortie operations for providing various inputs. And you can see the kind of results that have been obtained using this. And this particular instrument, we are working on making it further miniaturized to less than 5 kilograms and few tens of the watts as the power system. And this is another example of how space technology can be used for various ground applications. Today, we are working with not only industry and academia, a large number of response projects are in place and technology transfer activities are in place. And these are only going to increase because the department has set up a capacity building program office, which has taken up in a big way interaction with academia and industry and trying to see how we can make use of the Make in India concept, which we have been actually utilizing right from our early days of sounding rockets to now. And these capabilities are only going to increase. And as you are aware, the space has a huge potential, and the Indian industry actually can take advantage of the capability that has already been built and then not only provide solutions to the country, but also it can provide solutions across the globe and then actually capture a portion of the space market and then through that actually contribute to India's development and growth. And the opportunities are tremendous, and there is in the Aero Show also you will see a large number of interactions that are going to take place, and this is an excellent opportunity to make use of the tremendous market that exists in the country, both for people within the country and also from people outside, and leverage the technological build that is happening in the Indian industry, whether it is ISRO or institutions like HAL, BEL, ECIL, or any number of Indian industries. They all are now getting into this business of aerospace. And I think this is an opportune time to the industry within the country to take advantage of the technological progress that has been made. And I think this is in a nutshell what I wanted to communicate. And I'd be more than happy to take a few questions. Thank you very much for the patient hearing.
Thank you, sir. Thank you, sir. Now it is time for the question answer session. I would request the team at HL to please post the questions on the screen.
Yeah, Rajiv, can you read the question?
Yes, I can. How do we defend our satellites in view of growth in space militarization?
Okay, this is an aspect, of course, we need to worry as the time progresses, because the issue of space assets and then ensuring that all your assets continue to perform at the time of need is a requirement, and these aspects have to be dealt with as we keep progressing. Next one.
Radiation
hardening. Yes.
Radiation hardening. Please elaborate how it is done.
Okay, currently the radiation hardening can be done in two ways. One is by actually intrinsic design of the semiconductors. Other one is by actually providing some kind of a heavy metals which reduces some of the radiation that can enter into the chips and device, and both ways can be adopted.
There is very less students are interested in space program or astrophysics. Is there any way that we can bring in these interests in the space technology?
No, today if you look at in terms of the interest of aerospace technology and astrophysics, it is gradually growing. So far what had been happening is within the country, you are not getting actual data from the satellites, virgin data, but AstroSat has made a difference. Today the Indian researchers are getting this data, first time look at such data. And as we have already going on programs like Chandrayaan-2, follow on to Mars mission, Venus mission, Aditya mission. So there will be opportunities for them to get virgin data. And I'm sure activities on which is going on in space will actually give a fillip to their interest.
Can you please provide more information on pseudo-light-based navigation satellite? What technologies are still required for India to complete Gaganyaan?
Okay, in the pseudolite, what is being attempted is, see, you are providing on ground a number of reference signal generation, and these reference signals are actually received in the either the aircraft or any of the moving body, a receiver. And in fact, we have developed all this technology, and we are actually going to demonstrate this in one of the field trials, and we are involving Aeronautical Society as well as other industries, and then these pseudolights can make of course this will require certification subsequently, but it's all possible, and today the technology is under development.
Sir, is there any upcoming project or planning for reusing of launch vehicles like SpaceX?
Yeah, it's not exactly like SpaceX, because today our launch vehicles in the first stages we make use of the solid motors, but actually we have started the process of reusable launch vehicles, bringing back the various stages, and then our next version actually in the RLV-TD demonstrator is this version will land on the Sriharikota land strip or one of the land strip in the country. So the process is on. We are working on various technologies for ensuring that we can bring back many of the stages and thereby reduce the cost of access to space.
Why are we not going for a global GPS and limiting it to a regional one?
Okay, so what you can really visualize is the India by virtue of what resources it can make available. First, you have to prioritize your developmental activities. Today, what we are trying to do is make the best use of the resources and provide effective solutions to the country's problem. So what NAVIC enables is India and surrounding India up to 1500 kilometers beyond its borders, it is providing this solution. So this is the immediate need. As we can, our affordability of resources improve, we will get into global technology. It is not for want of technology we are not doing, but it is to maximize the returns for whatever resources that we have. If you look at the entire Indian space program has been actually appreciated by the rest. It's only because of this. we are making the maximum or the best use of the technology for providing effective solutions to the problems we face in the country.
So can we achieve a manned space mission by 2022? Is it practical?
Yeah, see, what you have to appreciate is, while ISRO had been working on this program for a long time, doing certain critical technology activities, unless you set a serious target and work towards the target, things will not move. And that is where the government's idea of setting this target of 75th anniversary, before the 75th anniversary of our independence, we should have our humans from India going up into orbit and coming back safely, makes a huge impact. And ISRO will put all its might and effort to achieve this success.
So can you please shed some light on the reliability studies onto the space vehicles?
Yeah, reliability is a key component. As you can visualize, in a launch vehicle, any one system or subsystem failing means the end of the mission. So you need to make sure that you build in enough alternates wherever there are likely to be a higher probability of failure, and then make sure that all the subsystems, etc., are designed in such a way that there are no single point failures. And wherever there are going to be such failures, build in redundancy in the systems. And then by this kind of a systematic approach of identifying elements which can fail, under operating conditions, going through a series of whether you call failure mode, effect and criticality analysis, or stress analysis, by conducting a series of such evaluations, you have to build into the system a reliability. And it's a continuous process. You can visualize, for example, in PSLV last year, we did face a problem, though almost 40 plus vehicles had successfully performed in one mission under certain extremes of environmental condition. We had gone beyond the 6 sigma limit and there was a failure. So we had to improve the robustness of that. So it's a continuous process.
So can we, how can we safeguard our space assets from threats like anti-satellite missiles?
Yeah, I thought we answered this question already.
How do you see the adoption of model-based design in ISRO projects?
Model-based design is one of the key things which happens all the time, because wherever simulation can be done, that simulation is being done. And wherever simulations are, even when you have done the simulation, many of the actually versions are built and then they are actually tested.
How miniaturization increase the performance of PSLV and GSEV?
In PSLV and GSLV, miniaturization, when we talk of miniaturization, we are talking of miniaturization of electronics primarily, because as you can visualize, the amount of fuel that you have to carry, amount of thrust you have to produce will not change unless you change your propulsion technologies itself, unless we come up with a newer chemical propulsion system which can do per kg much more than what it is doing today. Miniaturization of that is not possible. Today, miniaturization we are talking about is primarily in terms of electronics, and that you are seeing examples of mini satellites, etc., being flown and then tested out.
Material technology is where we have lagged for a long time, coupled with technological denial. It has been restricted our progress. What is ISRO planning to develop not only current but next generation materials?
Yeah, one of the key things is today we are concentrating on ensuring that our self-reliance, not self-sufficiency, you should distinguish the two. In terms of self-reliance, what we mean is we should be able to do the job even if there are some denials at some parts. Whereas self-sufficiency means everything we are doing ourselves. We have gone with the approach that whenever some components or some materials are available from multiple sources, then we are ready to take a chance. But then we start work on those things, and then for future, we will make sure that it's available. Today, we have a large number of material development activities going on in various ISRO centers, and we are also supporting entities like Midani and other academic institutions for development.
I think some people are able to
Yeah, a couple of online questions.
Thank you, sir, for answering so many questions. Now I request the participants to raise your hands if we can take 1 or 2 questions live. Well, I guess most of the questions have been answered, so no live questions for this session. Thank you, sir, for answering all the questions, and this has been such an interesting and educative session. Now I would hand over to Mr. Sunil Kumar for a few words.
Thank you, Mr. Kiran Kumar, for the very enriching insight into the Indian space program and future technologies needed for ground aerospace activities. We are lucky to hear from such an eminent personality who has seen it all through and has been instrumental in putting our country in the forefront of space technology in the world. The details of the future programs are definitely an industry enabler, paving the way for a greater industry participation and a billion opportunities. I also take this opportunity to thank Digital India, NEGD, MOD, INAE, ISRO, and AESI for organizing the webinar today. A special thanks to all the participants. Thank you, ladies and gentlemen. I now hand over to NEGD for the closing remarks.
Thank you, sir. Please note that this session is also available on the Digital India Learning YouTube channel. You can watch the whole webinar and all the previous webinars on this YouTube channel. Please subscribe so that you get notifications for all our upcoming webinars too. Now let me share my screen for the next webinar. So now on your screen, you see that the next webinar is scheduled for 6 February 2019 at 3 p.m. Indian Standard Time. It is being conducted by Shri Sharad Sharma, co-founder, iSpirit Foundation, and it is on the topic, Indian Drone Regulatory Regime, Innovative Business Opportunities. I hope you join us for this webinar as well. Now, I would take this opportunity to give you a tour of the Aero India website so that you can join the webinars and see the information available on the webinars. So on your screen, you see the Aero India website. Here you have the webinar tab. Click on the Join Webinar tab. When you click on the Join Webinar, you see all the list of webinars, the speakers, their information, their bio is also available. The links are available for you to join in. There are 2 webinars now left on 6th and the 13th February. I hope you join us. Now, before I end, I would like to thank Mr. M.S. Rao, President and Chief Executive Officer, National E-Governance Division, Dr. Ajay Kumar, Secretary, Defense Production, Shri Barun Mitra, Additional Secretary, Defense Production, Shri Vijendra, Joint Secretary, Naval Systems, and CVO, DDP, Mr. A.S. Kiran Kumar, our main speaker for today. Thank you, sir, for your precious time and giving us this knowledge. Captain Roy Joseph, also from Department of Defense Production, Mr. Sunil from HL, Mr. Naresh from HL, and also, last but not the least, the Digital India LMS team here at NEGD for making this webinar a huge success. With this, now I conclude for today. Hope to see you for the next webinar. I hope you had an enjoyable session. Happy learning. Jai Hind.
Thank you.